We are here to discuss about standardization. Hi, my name is Hermino Rajek and I'm going to discuss about standard, the ISO, and ANSI and their examples. But first of all, what is standard? Standard is universally or widely accepted, agreed upon, or established means of determining what something should be. What is ISO? ISO stands for Internationally Standard Organization. It's a worldwide federation of national standard bodies from some 100 countries with one standard body representing each member country. The ISO 3166 ISO 3166-1 and it defines for the names of countries, dependent territories, and special areas of geographical interest. The Part 1 is called country codes, and the Part 1 have three types, which is the Alpha 2, Alpha 3, and numeric. The Alpha 2 consists of two-letter country codes, which are the most widely used for the three, and used most prominently for the Internet's country code sub-level domains. The Alpha 3 consists of three-letter country codes, which allow a better visual association between the codes and the country name than the Alpha 2 codes. The numeric, it consists of three-digit country codes which are identical to those developed and maintained by the United Nations Statistics Division. Here are the examples of the Alpha 2, Alpha 3, and numeric. For example, Afghanistan, the Alpha 2 code is AF, the Alpha 3 is AFD, the numeric code is 004. The ISO 3166-2 ISO 3166-2 is defined codes for identifying the principal subdivision, provinces, or states of all countries. And here are the example. CA stands for Canada, and it has 10 provinces, 3 territories. Philippines has 17 regions and 80 provinces. The ISO 3166-3 it's code for formally used names of countries, and here are the examples. The ISO 4165. This standard is to describe the appliances in vehicles. What the standards in vehicles? The standard describes a double pole DC connector to supply between 12 and 24 V DC at up to 12 amps. It must be 20 mm in diameter. The resilient neck must mate with a 12 mm diameter hole. The center pin is 5 mm in diameter. And here is the example. The ISO 18004. QR code is a metric symbology consisting of an array of nominally square modules arranged in an overall square pattern. And here is the QR code. Squares. Symbol structure. Each QR code symbol shall be constructed of nominally square modules set out in a regular square array and shall consist of an encoding region and function patterns, namely finder, separator, timing patterns, and alignment patterns. And here are the parts of the QR code. In the above we have the quiet zone, which is blank. It's quiet. QR code, there are 40 different sizes. We have the 21 modules in the left, the 25 modules in the right, The 41 modules, the 45 modules, the 73 modules, 177 modules bigger, and the 101 modules. What is ANSI? Is the primary organization for the fostering the development of the technology standards in the United States. The N43.2. It talks about radiation safety for X-ray. ANSI C245.1. It's applicable to all persons engaged in the manufacture, modification, operation, cleaning, maintenance, service, or repair of mobile collecting, transporting, and compacting equipment. It attempts to distinguish between persons who may be the illegal owner, lessor, or who are otherwise contracted with or hired to become involved with the equipment. Excluded from this standard is equipment used for the collection, transportation, or disposal of hazardous or flammable materials. The ANSI C535.6. The 516 C535 standards contain recommendations regarding the formats, colors, and symbols for safety signs used in environmental and facility applications, product applications, and accident prevention tags tape, but do not address safety messages in product manuals, instructions, and other collateral materials. To respond to this need, the new standard provides a hazard communication system developed specially for product safety information in collateral materials, like signal words, danger, warning, caution, and notice. The safety alert symbol, safety colors which is red, orange, yellow, and here is the example.
I'm Sheila Kihara discussing the Japanese industrial standards. What is Japanese industrial standards? Japanese industrial standards specifies the standards used for industrial activities in Japan. The standardization process is coordinated by Japanese Standards Association. And here are the examples of Japanese industrial standards or the JIS. JIS H3330-2003 are the plastic covered copper tubes. Plastic covered copper tubes specifies the seamless copper tubes covered with plastic resin on the outside surface, which are used for the pipings for water supply, drainage, hot-cold water supply of air conditioners, and other pipings with working of 1.0 MPa or under. Plastic covered copper tubes was established on December 12, 2000, confirmed on October 1, 2008, and revised on October 20, 2008. Streamlined plastic coated copper tube is manufactured in a variety of options for use when copper tube is to be buried or used in a potentially aggressive environment. And here are the example pictures of plastic covered copper tubes. Plastic covered copper tubes, it can be used in a wide variety of situations including reclaimed water applications, the movement of natural gas, to name a few. Then, the JAS H8300-2011 or the thermal spraying zinc, aluminum, and other alloys. Thermal spraying zinc, aluminum, and their alloys. This Japanese industrial standard specifies the thermal spray coating of zinc. aluminum and their alloys which are processed on steel for the purpose of corrosion prevention. However, the standard does not apply to the preparation of thermal spray coatings. Thermal spraying zinc, aluminum and their alloys was established on May 1, 1971, confirmed on October 1, 2010, and revised on October 20, 2011. With a focus to apply the coatings industry with the most productive and reliable thermal spray equipment and plasma spray machines used in metallizing. And here are the example pictures of thermal spraying zinc, aluminum and their alloys. The next is JIS H8642-1995, or the hot dip aluminized coatings on ferrous products. Hot dip aluminized coatings on ferrous products. This Japanese industrial standard specifies the significant surface of hot dip aluminized coatings, hereafter referred to as coatings applied to ferrous products for the purpose of increasing weather fastness, corrosion resistance, and heat resistance. Hot dip aluminized coatings on ferrous products was established on October 1, 1965, revised on June 1, 1995, and confirmed on October 1, 2010. These articles having a coating containing about 55% aluminum, 45% zinc, 2% silicon are known to exhibit an optimal combination of general corrosion resistance, more durable than zinc coating. And here are the example pictures of hot dip aluminized coatings on ferrous products. Hot dip aluminized coatings on ferrous products. It has now been found that coatings containing 12 to 24% zinc, up to 4% silicon, balanced aluminum provide galvanic protection equal to or superior to such known coatings, while providing enhanced general corrosion resistance, approaching that of aluminum coatings.
Industrial study illustrates the specified components of an application or component to an industry standard. Objectives. The typical objectives of an industry standard are to ensure that the application or component complies to an industry standard, such as company or organizational standard, national industry standard, and international industry standards. Examples of the industry standard is the application shall conform to the code version including the ISO 10646 and ISO 1064661. Standards for car set encoding as specified by the Unicode organization. The application shall use the ISO standard codes for units of measures as specified by ISO 31. To the extent that is practical, the application shall consist of 100% pure Java using of Sun Enterprise Java Means technology and the Java 2 Platform Enterprise Edition. In this figure, we can see the comparison of ISO 9001-1994 and 200 table of contents. Thus, one important new element is ISO 101-2000 is the requirement to actually measure processes, products, and quality objectives. recognizes that the measurements are important, vital in fact, or if organizations are going to have any chance of assessing, monitoring, and improving the quality of their product or service. At this time, ISO 9001 is the only standard and the ISO 100 family against which third-party certification are carried out. Note, however, that the focus of this document is one of the requirements themselves and not on detail of the actual measurements. Thus, concerned with the metrics, the identifications, and the actual measurement of specific parameters is one of the prime focal points of this industry, specific derivatives. With the basic parameters and their associated metrics clearly identified for a specific industry, a template for more focused measurement can be developed. Section 2, dealing with customer-specific requirements, is not directly correlated in any way with IOS 9001 requirements. We can link table 2 IS2 1001994 elements versus ISO 90002000 elements. Summary. The RIAC website, http://www.riac.org, has an extensive listing of documents identified in this article and other potential scalability, maintainability, and quality qualifications and standards. The website listings include already recognized national, international, and military documents found under the heading R&M standards that may potentially be considered for applicability beyond their traditional applications. Certainly, a great deal of the groundwork has already been performed in the preparation of these documents. Information shall already be compiled and assembled by knowledgeable experts into potentially useful formats.